All right, let's take a look at your homework questions, which were on this forces review sheet. First one says a boy pulls with a horizontal force of 50 newtons. So F going this way is 50 newtons. Of course, Fg is acting down, and Fn will be acting up. On a 300 Newton wagon, so what I'm actually giving you is the Fg, the weight, okay? If the coefficient of kinetic friction is 0.1, so mu is 0.1, and friction then would be acting back this way. What is the acceleration of the wagon? So you're looking for AX. And how far does it move in 2 seconds? So that's going to be kinematics after we get there. All right, so always we start with these questions and sum of the forces in the y direction. This wagon is not moving in the y direction. So the sum of the forces, we have Fn going up and an Fg going down. So it'll be Fn minus Fg equals 0. Take your Fg over, so Fn equals Fg, which is equal to mg. And we know that's 300 newtons. So we could actually find our m here, because Fg equals mg. So m equals 300 newtons divided by 9.81 meters per second squared. Okay, so you could get your m. It's going to be 30 point, I think it's like 5.8 or something like that, kilograms. All right, so we have our Fn equals our Fg equals our mg. And so now we go to sum of the forces in the x direction. And it is moving in the x direction. It's actually what you're trying to find. So what are the forces? There's the 50 Newton force that you're pulling with, or the boy is, and friction, which is opposing you. So it has to be minus friction is equal to max. Okay, so you're actually solving for ax, so divide both sides by m. So it'll be F, and friction, we know, is really mu Fn. And what we found here was that Fn was equal to Fg, and Fg was 300 newtons. So we can do Ax is equal to 50 newtons minus mu was 0.1 times 300 newtons, should be about 30, divided by 30.58 kilograms. So on the top you get 20, and on the bottom you have 30.58 kilograms. So you should get an acceleration of 0.654 meters per second squared. Okay? Now the second part of the question says how far does it go? So you have the acceleration and you have the delta t, and you know it starts from rest, and you want to know how far does it go delta d. So part B would be delta d is equal to vi delta t 1/2 a delta t squared. This goes to 0. So 1/2 0.654 meters per second squared times 2 seconds squared. 2 squared is 4, half of 4 is 2, 2 times, so 1.308 meters, I believe, but I'm doing it in my head. I could look at the answer. Oh, it's 1.308. All right, number 2. Put my number 2 up too high. Here's my box. It's a hockey puck, really. Given an initial velocity of 20 meters per second, so its VI is 20 meters per second, okay? On a frozen level pond, the puck remains on the ice and slides 120 meters, so delta D is 120 meters. Before coming to rest, VF is 0. Determine the coefficient of friction between the puck and the ice. Now if we put our forces in, there's going to be an Fg going down and an Fn going up. And if the puck's moving this way, then friction must be acting backward. But it says it's given an initial velocity, so you hit it. You maybe did a slap shot or a wrist shot or something, and you gave it that initial velocity, but then there's no forward force after that. It's moving down the ice. You're not following it and still pushing on it. So there's no F here, which is what usually screws people up. They put an F in and then they don't know how to find it because it doesn't actually exist. Okay, so the first thing we can find is our acceleration because we have a VI, a VF, and a delta D. So we can do VF squared is equal to VI squared plus 2A delta D. And then we're going to rearrange for A. So A is equal to VF squared minus VI squared over 2 delta D. The VF is 0, so it'll be negative brackets 20 meters per second, don't forget to square it, over 2 times 120 meters. So on the top 40, on the bottom 240. So 40 over 240 is 1 over 6. And 1 over 6 is what? 0.3 repeating, and it'll be negative. So negative 3.4, oh, it's 400 after me saying don't. 400 over 240. 40 over 24. 8 goes in. 5 over... now I'm going to have to do it on the calculator because I don't trust myself. Isn't it 5 over 4? 1.2? Maybe not. 20 squared divided by 240. Can you tell it's late? 1.6 repeating. Oh, I forgot. Yeah. 1.6 repeating. I don't know. I think I forgot that too. 240. Or else I'm right and this is wrong. We'll find out as I go along. All right. So now we go back here. We do the sum of the forces in the y direction. The puck stays on the ice, so it's not moving in the y. So Fn minus Fg is equal to 0. So Fn equals Fg equals mg. This time we couldn't find it if we wanted to because we weren't given an m. So now we go to sum of the forces in the x equals max. And there's only one. It's friction. And it's opposing motion, so it goes in as a negative, is equal to max. We know friction is actually mu Fn. Is equal to max. We're solving for mu, so mu will equal max over negative mg. The m's cancel. The a, I still think, anyway, the a is negative 1.6 repeating, even though in my book I have 3.3 repeating, over negative 9.81 meters per second squared. Oh, look, and then I have the right answer. So clearly I screwed up and then I fixed it, but I didn't fix the rest. So positive 0.1699. Phew, I was like, okay, what's wrong with my head that I can't get the answer I've written down there? Something was wrong with my head earlier. Not now. Number 3, you're sliding an 80 kilogram box. So draw your picture, 80 kilogram box, along a flat level surface whose coefficient of friction, mu, is 0.4. If the box is accelerating, A, at a rate of 2.5 meters per second squared, we have an Fg going down, must have an F going this way, an Fn going up, a friction going backwards. So if the box is accelerating 2.5 meters per second squared, with what force parallel to the surface are you pushing it? So start out some of the forces in the y. It is not moving in the y. So you'll get Fn minus Fg equals 0. So Fn equals Fg equals mg. You could get a value here. I would urge you not to, though. Just carry the mg and put the numbers in later. And instead go to sum of the forces in the x. And in the x direction, you have F minus friction is equal to max. And you're solving for F. So take the friction over, max. And friction is really, it's going to be plus, it's really mu Fn. And now I would fill my numbers in. M is 80 kilograms. A is 2.5 meters per second squared. Mu is 0.4. M is 80 kilograms times 9.81 meters per second squared. First term is going to give you 200. Second term is going to give you 113 or something like that. And you get 313 Oh no, this is the second term, 313.9, so you add it together and you get